Hello, this is Topolgin, and today we're going to look into how to find the break-even point for alternate routing, the break-even quantity of products for alternate routings. At one point, you are going to decide if this amount of products is going to be built in machine one or in machine two, depending on the quantity that the purchase order calls for, or the PO calls for. So it's just a little bit of algebra, a little bit of calculation, and we're going to take a look at a couple of examples and end up with a calculator in Excel. So here it is. We have machine one, which is a very manual machine, and machine two, which is a more automated machine. Machine one has a setup of 1 unit of time. Let's say in this case is a minute, 1 minute, and a processing time per piece of 2 minutes. Machine 2, more automated, that needs more tooling and obviously setup and according to the blueprints and everything for that product, takes not 9 minutes and 1 minute of processing time. What we want to find out is this delta. What is the break-even quantity? In other words, the quantity in which producing delta amount of products is going to be the same, is going to cost us the same as far as manpower or money that goes into our manpower to build on machine one or on machine two. It doesn't matter. Either one is going to give us the same cost. That quantity we need to find out because when we find it, we can say in our ERP system, we can set up our ERP system, SAP for example, to have an alternate routing of from one piece to delta pieces. If the PO calls from one piece to delta pieces, uh, build on machine one. If not, or work center for machine one. If it's more than delta and it's beta and above infinity or whatever your ERP system uses as infinity, whatever number it uses as infinity, then it's going to be between beta and that infinity, right? And it's going to be built on machine 2, and that is for efficiency purposes and cost accounting and saving on costs and everything. So here's the equation, algebra, just quick straight up algebra. Setup time of machine 1 plus that quantity, that break-even quantity, times the processing time. So this is going to give us all this time from 0 seconds, no setup, all the way to whatever that amount of pieces is, what that break-even quantity. Uh, then setup 2, it should be equal that time, as we can see here visually, that time should be equal to setup 2 plus processing time 2 times the same quantity. Okay, so it's just an algebraic equation. We do all the operations and we end up with this formula. So delta should be equal or more than setup time on machine 2 or work center 2 minus setup time on work center 1 divided by processing time on work center 1 minus processing time on work center 2. Very simple, very straightforward, and we find our quantity. Let's look at a couple of examples here. Well, the first example uses the same numbers, the same units of time as our first tab, which is 1 minute setup time, 2 minutes processing, 9 minutes setup time, 1 minute processing. So 1, 2, 9, 1, same thing. So when we substitute all these numbers in our formula, we end up with 8, even 8. So basically, it's telling us that if we're going to build whatever this product is, and we're going to build 8 pieces of it, it it's going to cost us the same on machine 1 than on machine 2. The time is the same. For some reason, it ends up at the same time. So what I call the optimum quantity, which be 8 plus or 9, from 9 to infinity, you build on machine 2. From 1 to 8, you build on machine 1. Okay, so now uh, let's look at another example where the time it takes to build certain amount of pieces is not the same. Like in this case, let's say a setup time of 2 minutes, processing time of 3, and then machine 2 is the same, the same amount of time, the same units of time that we've been using for the last two tabs. So we substitute these numbers in the formula, and we end up with 3.5, 3.5 pieces. That's a break-even quantity. When we have to build 3.5 pieces, it doesn't matter if we build it on machine 1 or machine 2, it's going to be the same amount of money. Problem is we cannot have, for the most part, or it doesn't make sense to have half of the fourth piece built on machine 1 and then half on machine 2. So what we say, or what we're going to assume, is that 3 would be our break-even quantity, even though it's cheaper on machine 1. But then if we go to 4, we finish 4 pieces before in less amount of time on machine 1 than on machine 2 than on machine 1. So in this case, our alternate routing should be from 1 to 3 build on machine 1, or cost center 1, work center 1, or from 4 to infinity or whatever, build on work center 2, machine 2. Now let's look at the calculator. This calculator is locked. You only can input uh, numbers here. Any inputs, by the way, on this blog and video blog, we use this color of cells, green cells, and yellow numbers. That means input, user-defined input. So let's substitute. Let's say 1 minute setup time, 2 minutes processing time, and then let's see, 1 minute setup time, 2 minutes processing time, and 9 minutes and 1, 2, 9, 1. And we end up, as we said before, from 1 to 8, routing 1, from 9 to infinity, routing 2. Let's substitute our second example. This is 2391. 2391. And for our second example, we end up with what we already knew. But we can substitute anything. Let's say our setup time is 5 minutes and our processing time is 1.5 minutes. So what would that quantity be? Still 9. Let's say here takes 60 minutes and 1 minute processing time. Oh, so now it's from 1 to 110, and we can say that from 111 and beyond, there you go, 111 and beyond, we should build on machine 2, and that's just for efficiency purposes. It's more efficient, better use of resources, in this case manpower, probably energy too, time is money, to build on machine 2. This is assuming that both machines use only one person, one associate, one team member. So the same amount of manpower. We don't have to multiply by two or three or whatever. Uh, Basic simple assumption, basic simple calculator. I hope it added value to you. Thanks for watching.